we present a learning approach for training a single policy that imitates multiple gaits, such as trot and static walk. Specifically, we want to learn a policy that takes gait and reference commands and replaces its Model Predictive Control teacher for the computation of the control inputs. The policy is trained with an imitation learning approach called MPC-Net. MPC data are generated by sending the robot with different gaits to various targets. MPC-Net differs from other approaches since its policy search strategy is to minimize the control Hamiltonian. To monitor the training progress, we perform rollouts with the current policy and compute metrics such as the survival time. We use a mixture of experts' neural network to represent the policy. Moreover, we observe that the performance of a policy improves if each expert specializes in controlling exactly one mode of a hybrid system, as shown here for different contact modes of our robot. To achieve this kind of expert selection behavior, we present dedicated loss functions in our paper. We benchmark our approach against behavioral cloning and the original MPC. As shown on rough terrain, which was not part of the training data, MPC-Net outperforms behavioral cloning. In addition, compared to real-time MPC, MPC-Net policies achieve similar robustness on rough terrain. This robustness transfers to hardware. The robot's policy can also execute multiple gaits. As we intended with our approach, a single policy can learn several gaits, such as trot, as shown before, as well as static walk and pose control, as shown next. To demonstrate the generalization, we let the policy alternate between the learned gaits, although the transition was not part of the training data. Finally, we tested in simulation how our method scales to more than 2 gaits and added dynamic diagonal walking to the multi-gait training.